welcome back to my channel S Chemistry. My name is Sonal, and in today's video we are going to talk a little bit more about the structure of hemoglobin. Now, why am I saying a little bit more about the structure of hemoglobin is because I've already posted one video on my channel on the chemistry of hemoglobin. So I have covered hemoglobin as a biomolecule in that video, and what I have focused on is the chemistry of it, like with respect to the central metal atom iron, which is present in hemoglobin, the chemistry of that. Okay, if you guys haven't watched that video yet, then I will put the link in the description box. Please go watch that video and then come back to this, because I'm sure if you want to study the chemistry of hemoglobin, then that video will definitely help, and then this will help you tackle the structural aspect of hemoglobin. Okay, so this is a second video on hemoglobin wherein we will strictly talk about the structure of hemoglobin. Okay, and I will be making a third video of hemoglobin wherein I will tell you how can you easily draw the structure of hemoglobin, because as we know it's quite a complex structure. So I will help you guys or give you guys ways of drawing that structure in simple terms. Okay, so with that being said, let's start with the structure of hemoglobin. So first what we are going to do is we are going to break the word hemoglobin into two sections, because that way it's going to be easier for us to study the structure of hemoglobin. Okay, hemoglobin, for your general information, is the oxygen carrying pigment which is present in the red blood cells, and the color of red blood cells is red because of the presence of hemoglobin. Okay, now hemoglobin, when we want to do the structure of it, we're going to break it into two parts. Okay, it's like you're breaking the word itself into two parts. So I'm basically breaking it over here. Okay, so I have the heme part and then I have the globin part. Okay, so this is the first part and this is the second one. Okay, I have heme and then I have globin. You club them together, you will obviously get hemoglobin, right? Okay, now let's look at the individual sections. Yeah, first we will look at what is heme, and then we will look at what is globin. Okay, because let me tell you, the structure of hemoglobin is quite complex. Okay, and if you want to study it like that only, it's fine, but I personally would like to break it into two sections and then proceed further. Okay, so we have done that already. We have heme and then we have globin. Okay, now heme part represents the pigment. That is the first thing we have to note. Okay, heme part represents the pigment and globin part represents the protein chains. Okay, I will repeat again. Heme part represents the pigment and globin represents the protein chain which is present. Okay, let's take one step further. The heme, which is the pigment part of hemoglobin, can further be categorized into two sections. Okay, first is with respect to the central metal atom, or we can also call it as the metal ion, which is present in hemoglobin, which is iron in the +2 oxidation state. Very important to note, iron in the +2 oxidation state is known as ferrous. Okay, ferrous is in the +2 oxidation state and ferric is in the +3 oxidation state. Lower oxidation state gets an ending of OUS and higher oxidation state gets an ending of IC. For example, I'm just writing it over here. Fe3 plus is ferric. Okay, Fe3 plus is ferric, Fe2 plus is ferrous. Now obviously we are not going to talk about ferric, we will only focus on ferrous. Okay, let's come back. Hemoglobin, we broke the word into two parts, heme and globin. Heme represents the pigment, globin represents the protein. Okay, heme can further be classified, or you can categorize it into two sections. One is with respect to the central metal atom or the central metal ion, the metal cation which is present, which is your ferrous ion. Okay, Fe in the +2 oxidation state, and the other half of it, the other section of it, I mean to say, is porphyrin. Now porphyrin is a tetrapyrrole system. Okay, Now, what is a tetrapyrrole system? I will tell you guys in a bit. Okay. For now, we have the heme part categorized into ferrous and porphyrin. Okay. That being said, let's come to the globin part. We'll finish with the globin part because that is comparatively easier to understand. Okay. Globin is nothing but the protein chain which is present in hemoglobin. Okay. This globin can also be categorized into two types of chains. Okay. First category is of the alpha chains, and the second category we have are the beta chains. Okay. So the globin part is sectioned into two, alpha chains and beta chains. Okay. Now, alpha and beta, these are nothing but the protein chains, right? These alpha chains, beta chains, they are nothing but protein molecules, and we know that proteins are made up of amino acids. Okay, so basically alpha, beta, or the globin part, the building block, okay, the repeating unit in these systems is going to be the amino acids. Okay, I will just give you all like a general representation of amino acids. So in amino acids, what do we have? We have a carbon atom in the center. Okay, the easiest way to remember. Okay, we have a carbon atom in the center, and we know that carbon has a valency of 4, right? It forms 4 bonds. Okay, so carbon in the center, one side you put an NH2 group, an amine group, and one side you put a carboxylic acid group. Okay, C double bond OH. Fine. On one side you have a hydrogen in amino acids, and the last one is going to be any alkyl group. So you can represent it as R or R dash. Okay, but this R is like a variable. It will keep changing. Okay, so this is nothing but the structure of an amino acid. Okay, you have a carbon NH2 on one side, that is amine group, carboxylic group on the other side, one hydrogen and one alkyl group. Okay, now this group can be a variable, as I said. It depends, like the name of your amino acid depends on what type of R group you have. Okay, so that being said, alpha chains and beta chains are protein molecules, and proteins are made up of amino acids. Okay, now total in hemoglobin, in a molecule of hemoglobin, we have 574 amino acids. Important to note. Okay, total number of amino acids comprising of alpha and beta chains which make the globin part of hemoglobin, the total are 574. Okay, how do we get that 574? Obviously, it is the sum of alpha and beta. Yeah, alpha chains will have a contribution, beta chains will have a contribution. So in alpha chains, the contribution is such that basically now you can see I have written 141 into 2 and I have written 146 into 2. Okay, so these alpha and beta chains that we have, they are actually present in pairs. Okay, so there is like alpha 1 and alpha 2. Okay, like two chains, and then there is beta 1 and beta 2. Okay, there are two chains of these proteins or amino acids. Basically, when you have a large number of amino acids clubbing together in order to give you a protein chain, we call that a polypeptide, right? Polypeptide. Because these amino acids are linked through a peptide bond, okay, and a chain of amino acids is known as a polypeptide chain. Okay, so we have these two alpha chains and we have two beta chains. Okay, alpha 1, alpha 2, and beta 1 and beta 2. Okay, so one alpha chain consists of 141 amino acids. Okay, we have two of them, so that will become 282. Okay, similarly, one beta chain consists of 146 amino acids. Okay, we have two of them, so that will become 292. Okay, you add the number of amino acids, we will get 574 total amino acids. Okay, so in the globin part, we have alpha chains, two of them, alpha 1, alpha 2. We have beta chains, two of them, beta 1 and beta 2, and total they have 574 amino acids present. Okay, so the globin part is made up of 574 amino acids. Fine. So that is the globin part. Now we will jump back to the porphyrin system. So this is the structure of hemoglobin. Let's quickly go through it. Now parts of it we have already discussed, right? We are going to mainly focus on the pyrrole system, the tetrapyrrole system that we have. Okay. So in the center we have the ferrous cation or ion in the +2 oxidation state, okay, and around it the tetrapyrrole system is present, which is the porphyrin, right? Pyrrole is basically this ring you can see over here, okay. Pyrrole is a 5-membered ring wherein it's a heterocyclic ring wherein one of the atom is nitrogen, okay. So this is a pyrrole ring, this is a pyrrole ring, this is a pyrrole ring, and this is also a pyrrole ring. So we have 4 in total, and that's why we call it a tetrapyrrole system, okay. Now the nitrogen atoms from each of the pyrrole ring are linked, or they are attached to your iron atom, the central metal atom in the +2 oxidation state, okay. Next we need to see how these pyrrole rings are linked to themselves, okay. So they are linked to each other by methylene bridges. Can you see this particular bridge over here? Okay, the CH group over here. Okay, this is CH and then it has 3 bonds, right? These are the methylene bridges which are linking two pyrrole rings to each other. Okay, I keep saying rings and links. It's confusing. Okay, so I'll repeat again. Each of the pyrrole ring is linked to each other through a methylene bridge. Fine. So obviously, since we have 4 pyrrole systems, we will also have 4 methylene bridges. Okay. So we have the central atom, tetrapyrrole system linked to each other through methylene bridges. Yeah. Now let's come to the substituents which are present. Okay, let's come to the substituents. Before we do that, I just want to label some carbon atoms over here. Okay, so let me tell you. Basically, we can see there are 4 carbon atoms over here. 1, 2, 3 and 4. Okay, 2 carbon atoms which are linked on either side to the methylene groups. Okay, those carbon atoms are known as alpha carbon atoms. Okay, the carbon atoms which are linked to the methylene bridges are known as alpha carbon atoms. Okay, we are majorly interested in the other ones which are not linked. Okay, so the carbon atoms which are present over here are known as beta carbon atoms. Okay, and beta carbon atoms are of interest to us because that is where our substituents lie. Okay, so let's label all the beta carbon atoms that we have. So this will be beta 1, this will be beta 2. Okay, this will be beta 3, this will be beta 4, this will be beta 5, beta 6, beta 7 and beta 8. Okay, you will have alpha also 8 carbon atoms, fine, but beta is of our focus. Fine. Now you can see that beta 1, where all do we have the CH3 group? Beta 1, then we have it at beta 3, then we have it at beta 5, and then we have it at beta 8. So carbon 1, 3, 5 and 8, they are supposed to have the methyl group linked to them, the CH3 group basically. Okay. Now coming to the next one. Okay, so here we have beta 2 and here we have beta 4. Okay, the group present is CH double bond CH2 group. Okay, that is the group present at carbon number 2 and carbon number 4. Okay, now finally can you see this particular group over here? It is nothing but your CH2CH2COOH, which is your propanoic acid. Okay, propanoic acid is present at beta 6 and beta 7. 6 and 7 is going to be your CH2, CH2, COOH, which is propanoic acid. That particular substituent is going to be present at beta 6 and beta 7. Okay, there is more to it. The substituent, listen carefully, the substituent which is present at carbon number 6, okay, will have a lysine further attached to it, Ly, which represents lysine, okay, and the one which is at 7, beta 7, okay, the propanoic acid group present at beta 7 will have an arginine attached to it. So lysine at 6 and arginine will be present at position number 7. Okay, so this is the summary of the structure of hemoglobin. So we have done the entire porphyrin system. Now last one thing is remaining, and that is obviously the polypeptide chain. Okay, so this earlier we saw that the iron is in a 4-coordinate system. Okay, with the tetrapyrrole system and the substituents, you know, having your lysine amino acid, arginine amino acid, everything is done. Finally, it is connected to a nitrogen atom of the imidazole substituent which further is going to be linked to a polypeptide chain. So this is going to represent the polypeptide portion or the polypeptide aspect that is present in the structure of hemoglobin. Okay, so it is linked to a nitrogen of the imidazole group. Okay, and this is the link for your entire polypeptide chain, the entire chain of amino acids. So this is basically the entire hemoglobin system. Now one thing you have to note is that for one hemoglobin system, okay, you require 4 of such units, that is 4 iron atoms along with 4 tetrapyrrole systems and the entire polypeptide chain linked to it. Okay, 4 such units will make one hemoglobin. Okay, so with that I will stop today's video. If you all did like this video, then please give this video a thumbs up, and I will see you guys with the third part wherein I will help you to draw this structure in a very simple and easy way. Thank you so much for that.